Good evening, everyone. Welcome to Unacademy, India's largest online learning platform, which is helping the lakhs of the students across the country to realize their dreams, to realize their dreams. I welcome all of you and very good evening. So, quickly, what we are discussing is we are discussing a subject called electronic devices. We're discussing a subject called electronic devices. This is going to be lecture number 10, and this is Semiconductor Physics Part 10. And we are discussing here GATE, and which is also useful for ESC. It is Engineering Service Examination. Engineering Service Examination, right? Okay. So, okay, myself, Shravan Kumar. I have master's degree from JNTUH in VLSI System Design. I have mentored more than 10K students in GATE and ESC. So I have 10 years of teaching experience altogether. I have 10 years of teaching experience altogether. And the subject which I will teach is EDC. This is which we are discussing right now. Analog electronics. Some part of the analog electronics, especially op amps, is right now I'm discussing in the Unacademy app. Unacademy app. Please follow me in Unacademy app also for both EDC and analog, right? And we can also discuss digital and EMFT, digital and EMFT. So use my promo code, that is SVS 10, SVS 10 for 10% discount on plus subscription. For 10% discount on plus subscription. So what do you mean by plus subscription? So plus subscription means you'll get live classes. You'll get live classes. You can attend all the live classes which are going on. You can attend all the live classes which are going on, and you'll have a separate crash courses. You'll have a separate crash courses for time period, and you will have a weekly test. Sir, as I told you many times, this test is important. GATE is not just about listening. GATE is all about practicing. How much you practice, that much expert you will become in GATE examination. In GATE examination, and you'll have something called doubt solving sessions. You'll have something called doubt. Every 4th hour is going to be doubt solving session, which is very much interactive, and you can ask you can clear all the doubts, right? And the topics will be in English and Hindi. Lectures will be in English and Hindi, both languages. And we have something called rank improvement batch. So somebody who has already got some rank and they want to improve their rank, so it can be for rank improvement batch. This is for rank improvement batch. And we have iconic. We have iconic batch. In the advantage of iconic batch is you'll have a personal coach. You'll have a personal coach, and you'll have a study planner. You have a study planner. You'll have a study booster sessions. So for every essential subjects and how you have to they'll conduct regularly workshops, right? So this is very important. Study booster also, and personalized test analysis. After every test, right, what you write after every test, you will get a in-depth analysis for each and every problem, each and every question, what went wrong, where went wrong, everything will be given, sir. So how many marks you are going to get, how do you improve, all these things will be given. And you will have a very important other thing is you will have a notes, specialized notes you will have, and you will have a practice sets also. This is also very important for a plus students and iconic students. So the fees for a plus student, fees for a plus subscription for 12 months, it's going to be 27,225, and for 18 months, 18 months, that is for 2022, is going to be 34,650 rupees. SVS 10, again that's a promo code. And for 24 months, it's going to be 39,600. It's going to be 39,600. And you will have a something called SVS 10. SVS 10 is the promo code which you can use to get 10% discount on this. This is for plus. If you want to choose for iconic batch, if you want to choose iconic batch, for 12 months, the iconic batch fee is going to be 45,225. And again, the same promo code. For 24 months, it's going to be 66600. So again, you can use this promo code SVS10. This is a new initiative which will start on December 20th. Which will start on 20th. Free special class series. Please, free special class series by titled Know Your Basics. Know Your Basics, which will be used for useful for who are appearing for GATE 22 and 23. 2022 and 23. So what will they'll clearly explain what is the roadmap to approach each subject of every branch. So what branches you can have, sir? You can have a mechanical engineering, you will have civil engineering, you will have a electrical engineering, you have a ECE, you will have CSE, IT, and chemical engineering. For all these engineering branches, what are the different subjects and how to approach each subject to crack as much as possible, and how to study. All these things will be explained here, and understand subject-wise strategy. So which subject need to be concentrated more, which subject need to be given less important. All these things will be given in this course, right? Introduction and guidance by India's. So the top educators are there in the Unacademy. All the top educators of Unacademy will be starting this course, which will be starting from December 20th. Okay. And this is a paid batch. We call so targeting 2023. Targeting 2023, sir. This is targeting 2023. So those who are in second year, third year, they can target for 2023. 2023 called Ascend batch. This is Ascend batch. So this is for ECE, and sir, the classes will be in English and Hindi. The class will be English and Hindi, which will start on 21st December. Which will start on 21st December, sir. And these are the top educators of Unacademy. These are the top educators of Unacademy, and use a promo code of ECE GATE 10. ECE GATE 10 to get this into Ascend batch 2023. Ascend batch. This is for ECE. This is for ECE. For Triple also we have same Ascend 2023 for electrical batch. Electrical batch A. Batch A means first batch. Okay. So you'll have English and Hindi again. This also starts on December 21st. December 21st. This also starts on 21st of December. Again, these are the top educators of Unacademy. So who are well known across the India, right? So again, you can use this Triple GATE 10. Triple GATE 10. This is assigned for 2023, and we have something called Evolve. Evolve for this is GATE 2022. Next year, I mean 2022. For 2022, this is called Evolve. Evolve for 2022 and Ascend for 2023. And again, this is the first batch is going to be start on 21st of December, which is again batches will be in English and Hindi. English and Hindi. Again, the same faculty who are taking the Ascend batch will teach you here, who are also the topmost educators of Unacademy. And we have this is user code is ECE GATE 10. ECE GATE 10. And this is for Triple batch, I mean electrical batch, which also starts on 21st December. So this is Evolve 2022. Evolve 2022 is for students who are electrical here. So this is English and Hindi. Again, this also starts on 21st December. These are also again the most important faculty members of Unacademy. And the user code is going to be WE GATE 10. EE GATE 10. That is for EC, it will be EC GATE 10. Is that clear? So now this is important for me. You can follow me on Unacademy. So and this is the user code. So if you follow me, what happens is you will be notified all the sessions which I am taking. You will be notified all the sessions which I am taking on Unacademy app, as well as especially Unacademy app. especially Unacademy app. So what are the classes, different classes I'm taking, what are the free classes, what are the paid classes, what is everything is available. But I request you to just follow me on Unacademy. Follow me on Unacademy. Okay. So before going to start what we have discussed today, as usual, we will first start discussing about what we have discussed in the previous class. What we have discussed in the previous class. I think we have solved some problems. We have solved many problems here. 1, 2, 3, 4. So this was the IAS problem. 4, 5, 6, 7, 8, 9. Almost 9 questions we have discussed. 9 questions we have discussed. Now, yesterday also we have discussed something called effect of temperature on the conductivity of extrinsic semiconductor. What is extrinsic, sir? Extrinsic is nothing but an impure, right? How the conductivity changes. You can see here how it is changing. So I'll just recap quickly just for 2 minutes. In an extrinsic semiconductor, at a temperature T is equal to 0, at absolute temperature at T is equal to 0, there is no possibility of conduction at all. It acts as an insulator. Why? Because there is no possibility of the charge carriers at all. There is no charge carriers at all. So because of that, what happens, sir? It acts as an insulator. But as you change the temperature, as you move from 0 to 300 degrees Kelvin, so what happens is the electrons which are present in the covalent bonds will come out, will gain some energy. As the temperature is increasing, the electrons which are present will gain some energy and they'll come out. And as they're coming out, what happens, sir? This EHP will formation. What is EHP? Electron hole formation will happen. Electron hole formation will happen. So whenever electron hole formation is happening, the number of charge carriers are increasing. The number of charge carriers are increasing. When number of charge carriers is increasing, will they sit silently? No, they'll move from one area to other area. Yes or no? They'll move from one area to other area. So slowly what happens, sir? The conductivity of semiconductor will increase. So, conductivity of semiconductor will increase. So because you can see here, the N value is increasing and the P value is increasing. N value is and P value is increasing, right? Due to formation of electron hole pairs. Now this will continue till 300 degrees Kelvin. This will continue till 300 degrees Kelvin. This will continue till 300 degrees Kelvin. After 300 degrees Kelvin, so when you move from 300 degrees Kelvin to some other temperature Tc, so here what happens is slowly as the number of charge carriers are increasing, collisions will start, right? If a classroom has only 10 students, there is no issue. But if the classroom has filled with 50 students, obviously they'll start fighting with each other, yes or no? Fighting with each other. So similarly, if the number of charge carriers is increasing, what happens, sir? They'll collide. So because of that, what happens, sir? Let's say you're moving with a high speed. Suddenly something comes in between. So what happens, sir? You'll stop. Your speed will decrease. When the speed is decreasing, what happens, sir? The conductivity decreases. That's what we mean, right? So this will continue till some temperature Tc. This will come. What is called? This is called Curie temperature. Curie temperature. So what we mean by Curie temperature is the Curie temperature is the temperature where the values of N is equal to P. That is, majority charge carriers becomes equal to minority charge carriers. Majority charge carriers becomes minority charge carriers or minus whatever. Both N and P should become equal. So at this point, your conductivity will be minimum. After this point, what happens, sir? Earlier, the majority charge carriers were less. Now, at T is equal to Tc, they have become equal. Now, what happens, sir? This again, the majority charge carriers will slowly becoming minority charge carrier. Minority charge carrier become majority and majority becomes minority. So now what happens, sir? These levels are changing. Earlier the minority, now is majority. Earlier the majority, now the minority. Now because of that, now what happens, sir? Again, the conduction starts increasing. The conduction starts increasing. Is that clear? So this is what we discussed. Okay. We'll come back to our today's class. Okay, now the carrier concentration semiconductor. This is the most important topic. This is the most important topic to be remembered. So, and for that, you should know something called Fermi-Dirac distribution function. Why do we need this distribution function? Why do we need this distribution function? And this Fermi-Dirac distribution function will give us the probability of finding an electron. Probability of finding an electron. It gives the probability of finding an electron. It gives the probability of finding an electron. It gives the probability of finding an electron in the energy band. So very important, right? So see, in energy band diagram, the probability that energy level is occupied by an electron is given by Fermi-Dirac distribution function. So let me tell you clearly what does it mean. So what does it mean? I'll just try to explain you with energy band diagram. So this is the energy band which we have discussed in the previous cases. Don't think that the sizes are different. No, that just for sake of convenience I have written like this. This is what, sir? This is conduction band. This is conduction band. Whereas this is a valence band. This is valence band. So the electron which is already there in the valency band. Now, if it is free, so there are different energy gaps. This is the we call this as energy gap. Yes or no? We call this as energy gap originally. Let's say this energy gap is not existing. This is not a prohibited area. So now, if the electron is becoming free, and a hole is formed here. Now, the electron which is becoming free, where at what energy level it will occupy? At what energy level it will? So this is a band of energy levels, right? So you'll have 1, 2, 3, 4, 5, 6. You'll have hundreds of energy levels are existing. Hundreds of energy levels are existing. Now the electron which is becoming free, which has become free, where it will energy 3, some let's say energy n, energy level n. Let's assume you have n energy levels. So the electron which has become free, where it is going to occupy? Where it is going to occupy? This is very important, right? So this is very important. So the electron which has, so this, who will tell you this? How will you calculate this? The electron which has become free, which energy level it will occupy? This will be explained by this Fermi-Dirac distribution function. Fermi-Dirac probability distribution function. Probability function, right? So the probability that the energy level is occupied by an electron, is given by the Fermi-Dirac probability function. So which is equal to f of e is equal to 1 by 1 plus e power e minus ef by kt is e minus ef by kt, e minus ef by kt, where k is a Boltzmann's constant, in electron volts per degree Kelvin. Electron volts per degree Kelvin, which is equal to 8.62 10 to the power of minus 15 electron volts per Kelvin, or it's going to be 1.38 into 10 to the power of minus 23. 1.38 into 10 to the power of minus 23 joules per Kelvin, right? So then what is temperature? Temperature in degrees Kelvin, right? So T is capital T is the temperature Kelvin, and E is the energy level occupied by an electron. Energy level is occupied by an electron, and EF stands for Fermi level. EF stands for Fermi level. So what do you mean by Fermi level? What do you mean by Fermi level? What do you mean by Fermi level? Right? So what do you mean by Fermi level is? A Fermi level, the Fermi level EF indicates the probability of occupancy of energy by an electron in intrinsic semiconductor at absolute temperature, see, that is at T is equal to 0, the probability of finding electron in the conduction band is 0. Okay, and the probability of finding a hole in the valency band is also 0. Fermi level is defined as the energy state which has 50% probability of being filled by an electron if no forbidden band exists. This is important. No forbidden band exists. If there is no forbidden band, so the energy level where you can find the probability of finding electron is 50%. That is 1 by 2. That is 1 by 2. That is 1 by 2. So the EF for intrinsic semiconductor lie in the center of the forbidden band. That is EF is equal to EC. This is EC EV. This is EV. So this is going to be EC plus EV by 2. EC plus EV by 2. This is EC plus EV by 2. So what is this EC and EV, sir? So just now I'll try to explain you what exactly this means by a Fermi level. What exactly means by a Fermi level? Do not worry, I'm here to, as I told you, I'm here to explain you each and every concept very clearly. Each and every concept very clearly. Need not worry. Only thing is just listen to my class. Just listen to my class. Pay attention. Pay attention while you are discussing. Attend all the live classes. Attend all the live classes. Attend all the live classes. Mahendra, Vasu, good evening. Sorry, I missed it. Mahendra and Vasu, good evening. I missed it. Thank you for joining. So we call this as a conduction band. As you know, you already this is a valence band. Valence band, and this is called actually energy gap. So this level, the lowest level of this conduction band is called EC. It is the lowest level. And this is EV, the highest level of highest level of valency band is called EV. Is called EV. Right? Here generally electrons will exist. Electrons will exist in the covalent bonds. In the covalent bonds. So what is saying? What is saying? So the Fermi level is defined as the energy state which has 50% of probability. So where do you get this 50% of probability, sir? Where do you get 50% of probability? So obviously it is at the center of this or no? At the center or not? At the center or not? Huh? Yes or no? So even if you have doubt, so what earlier we are discussing? So we have f of e, that is, what is f of e? The Fermi-Dirac distribution function. Fermi-Dirac distribution function is saying f of e is equal to 1 by 1 plus e power e minus ef by kt. Yes or no? E minus ef by kt. Now if E is equal to EF, assume that E is equal to EF, E is equal to EF, then what is EF becomes? F of EF is equal to 1 by 1 plus E power E minus EF, EF minus EF, E power 0, E power 0. that is equal to 1 by 1 plus 1, that is equal to 1 by 2. So the probability of finding an electron, the energy state where the probability of finding an electron is 1 by 2, that is nothing but 50%. Probability of finding an electron, probability of finding an electron. Good evening, Syed. Good evening, Syed. So probability of finding an electron is 1 by 2. Probability of finding an electron is 1 by 2. Probability of finding an electron is 1 by 2. So that is 50%. So the energy level, the energy level, the energy level, the energy level where probability of finding an electron is 1 by 2 is called Fermi level. Fermi level. Assume that this energy gap is not there. This energy gap is not there. So this is represented by EF. This is represented by EF. So for this condition, so the energy state which has a Fermi level, this is called Fermi level. The Fermi level is nothing but the probability of finding electron is 1 by 2. So neither it will be close to EC, that is conduction band, nor it will be close to EV, valency band. So it will be at the center of this. So how to calculate this? How to calculate this? We know that EF is equal to the top EV, EC plus EV by 2. Need not worry, we will also calculate, we will derive this also. So at the center of this, we are going to get the Fermi level. The Fermi level, which is very, very important. Now let us say, now what I am trying to do is, so for this, if let us say this EV, this E is far greater than EF. EC is very, very far greater than EF. Now one more thing here I should tell you is, so consider for E is less than EF. If E is less than EF, what is F of E, sir? F of E is going to be 1 by, as I know, 1 plus E power E minus EF by KT. Right? If E is very less when compared with minus EF, EF is where, sir? EF is at the center. So I'm trying to say this is below, very below means, let's say it is at minus infinity. It is at minus infinity. So now what happens, sir? What we can say? So F of E is going to be 1 by 1 plus E power minus infinity. E power minus infinity. So how much this will become, sir? F of E is equal to 1 by 1 plus E power 0, sorry, E power minus infinity is nothing but 1 by infinity is nothing but 0. So the probability of finding an electron is 1. The probability of finding an electron is 1 for EF less than E. E is less than EF. For E is less than EF, probability of finding electron is equal to 1. Right? Probability of finding electron is equal to 1. Now let us consider for E is far greater than EF. It means the energy level occupied by an electron, is very far away from the Fermi level, So it means it is not here. It is far away from the EF, far away from the EF. So we think that it is going to be positive. So what we can write, sir? F of E is equal to 1 by 1 plus e power. Can I write e power infinity? Because I am saying this is e power. E is far greater than EF. So I am trying to say this is F of E is going to be e power infinite. So this is going to be e for infinity is 1 by infinity. So F of E is going to be 0. F of E. For EF greater than, EF, finding an electron, the probability of finding an electron becomes 0. So if we try to draw the waveform, I'm just trying to redraw this, sir. So as you did not understand this is a Fermi-Dirac distribution function. So first let me draw. So sir, assume all these things are happening at t is equal to 0. Sorry. So at t is equal to 0 Kelvin. This also at t is equal to 0. All are happening at t is equal to 0. So 1 means here 100% probability. Here 0% probability. So for EF it is going to be 50% probability. For EF it is going to be 50% probability. Now I'll try to draw I'll let you know why I'm drawing this. Assume this is going to be 0. This is going to be 0. And assume this is going to be the energy E. This is going to be energy E. Okay. And this is going to be F of E. F of E. Assume this is going to be EF. EF. So for energies, this is F of E is going to be 1 here. Right? At exactly EF. Exactly EF is going to be 1 by 2. It's going to be 1 by 2. Right? So this is this is E in the direction, right? So this F of E. Sir, we know that just now from here, what we can say here, for energies less than EF, probability of finding electron is 1. So this is why I have drawn this. So this 1, right? The probability of finding electron for E greater than EF, is 0. For E greater than EF is equal to 0. This is what I'm trying to do. So before EF, it is going to be 1. So before EF is going to be 1. After EF is going to be 0. So before Fermi level, probability of finding electron is 1. After Fermi level, the probability of finding electron is 0. So, but exactly E is equal to EF, probability of finding an electron is 1 by 2. Probability of finding an electron. So this is all true. When temperature T is equal to 0 Kelvin. Temperature T is equal to 0 Kelvin. Now, let's say as temperature is increased, let's say I'm considering a temperature, let some temperature T1 which is greater than T. Now, as temperature is increasing, what happens, sir? What happens is the number of charge carriers, electron hole formation will happen. So because of that, the charge carriers, Teshri, good evening. The charge carriers will come into existence. When the charge carriers are existing, probability of finding electron will become increased after EF. I'll show you. I'll try to draw now here. So now, as the temperature is increasing, the probability of finding electron looks like this. The probability of finding an electron. So earlier, the probability of finding electron was before EF is 0. But this is the probability of finding electron, sir. This is probability of finding an electron F of E. So you may get a doubt, then what is this, sir? What is this region? If this is F of E, this is going to be what? So this is going to be what? This is going to be 1 minus F of E. So what is this? If this is electron probability, then this is hole probability. So this is all true for a temperature of T1. Let's say the temperature again you increased. Next you got temperature T2, which is also greater than T1. Let's say you have a temperature which is greater than T1. So assume that T1 is greater than T. I think something is not visible here. That's the reason I'm writing here. So T2 is again greater than T1. So still you are trying to increase. When you still try to increase, now what happens, sir? Again, the probability of finding an electron. Now this is T2. Now complete this region. And this region. So this region is again probability of finding an electron. So as the temperature is increasing, probability of finding the electron is moving away from the Fermi level. Obviously, so then probability of finding a hole below the Fermi level is also increasing. Earlier it was 0. Yes or no? If probability of finding an electron is 1 here before EF, so obviously probability of finding a hole is 0. So here slowly what happens, sir? This is very important. The hole probability is also increasing. Electron probability also. As temperature is increasing, now what's happening? So temperature is increasing. Now what's happening, sir? Slowly, as temperature increasing, slowly electron hole pairs are coming, and electron hole pairs are coming. This Fermi direct probability distribution function is explaining how. Okay, so this is what a Fermi direct distribution function. Now, if you see it for an intrinsic semiconductor, now I'll try to draw. This is a valency band. and this is going to be conduction band. We know that this is going to be EF. This is going to be EF. This is going to be EF, and this is a conduction band. Conduction band, and this is going to be valence band. Now, if we try to integrate both, of them, so how it looks like, sir? I'll show you again. Assume that this is the energy E. This is the energy E, and this is F of E. I'm just trying to change the direction like this. I'm trying to change direction like this. Now, what you'll get, sir? You'll get the probability distribution function like this. So at EF, what you get is like this. At EF, what you get like this. What you get like this. Right? So this is a probability 1. This is a probability 1. This is a probability 1. And here it is going to be 1 by 2. It is going to be 1 by 2. It's going to be 1 by 2. It's going to be 1 by 2. Very clear. Be very clear. Now, as the temperature is increasing, now what happens, sir? Always possibility that. Always possibility that. So again, here the temperature is increasing. With very carefulness, I try to draw this. So I just trying to change this. I'm trying to change this. So this EF is at the center. So for intrinsic semiconductor, for intrinsic semiconductor, EF is equal to EFI. You can also call as intrinsic energy level. Intrinsic semi energy, because for it is going to N is equal to P is equal to Ni. For intrinsic semiconductor, N is equal to P is equal to Ni. N is equal to P is equal to Ni. So because of that, EF is equal to EFI is equal to EI. Sir, pay attention. This class is very important. This class is very important. Pay attention very carefully. Pay attention very carefully. Right? So for intrinsic semiconductor, this is what the Fermi Dirac distribution function. So now the next case, let's say now N type. So what will happen to N type? To draw the N type, I'm just trying to merge both of them. Here it is E, and here it is F of E. This is a valency band. This is going to be conduction band, and we call this as a EC. We call this as a E. We call this as EV. Now, interesting thing here is we know that in the previous discussion we have told that the energy level in an extrinsic semiconductor of type En will be very close to the conduction band. Will be very close to the conduction band. So we can call this now here as EF. EF for N-type. EF for N-type. So how the probability distribution function will be, sir? It's very simple. The probability distribution function will be like this. The probability distribution function will be like this. So as the temperature increases, now what happens, sir? Again, so it will never become zero. It will never become zero. So what it indicates? What this portion is indicating? This portion is indicating F of E. That is probability of finding an electron. So what this portion is indicating? 1 minus F of E it is indicating. Means here you have valency electron holes. Here you have electrons. Here you have electrons because it is a conduction band. Because it is a conduction band. In N-type, you will have free electrons. In N-type, why Fermi level is drawn near conduction band? See, in the energy, also in the last class, probably you might have missed this class. Whenever the new energies, new electrons of the valency electrons are come together, they will form a new energy level. They will form a new energy level. That is called energy distribution. Energy distribution. So we have in detail discussed in one of the previous classes. Just go back and see. Just go back and see. All this newly formed energy, all these newly formed electrons and holes will have their own new energy level, and that is very close to the conduction band. That is very close to the conduction band. Is that clear, Vasu? Is that clear, Vasu? So now this is what happens. So in N-type semiconductor material, we know that N is greater than Ni, or N is greater than P, of course. N is greater than P. So now because of that, the energy level is very close to this. Now what is this EC minus EF? EC minus EF. So EC minus EF, EC minus EFN will give us number of electrons present in N-type. Number of electrons present. Number of electrons present. Number of electrons present. Good Vasu. Good Vasu. So EC minus EF, this gap will give us how many electrons are occupied. How many electrons are occupied in this region will be given by, this is the energy difference, right? Energy band difference. This is also another energy band. This is also another energy band. So EC minus EF is equal to number of electrons present in N-type. In N-type. In N-type. So similarly, for a P-type semiconductor material, the p-type semiconductor metal. Let me again draw in the same manner how I've drawn for n-type. So for p-type, so this is what, sir? This is a conduction band. This is valence band. This is valence band. The other one is conduction band. And this level is called EC, and this energy level is called EF. Sorry, EEV. EV. EV. Now here you will have many holes, and we can call this EFP. We can call this as EFP. EFP. Now if you see the function, you see the function how it looks like. The probability distribution function. The probability distribution function. This is on f of E on, let's say, x-axis, and you're taking this is energy E. So now here the probability of finding a hole, the probability of finding a hole here is higher. Here electron is less. So again, now what happens, sir? If the temperature is increased, temperature is increased, so this is how probability distribution function looks. This is how the probability distribution function looks. Clear? This is how the probability of the distribution function looks. So what is this? This is 1 minus f of E. So what is this? This is going to be f of E. This is going to be f of E. Right? Then what is this gap gives us? What is that gap? This gap is nothing but E F P minus EV. EFP minus EV gives us a hole concentration. Gives us hole concentration. Gives us hole concentration. Gives us hole concentration. So this is what about how intrinsic, extrinsic, and n-type, p-type energy bands will look like. Energy bands look like. Then what is Fermi level, sir? Fermi level is nothing but EC minus EV by 2. That is, which is having 50% of probability. 50% of the probability. Which is having 50% of the probability. Okay. Now we will see the electron concentration at equilibrium. So this is a very important concept to be remembered. Few questions might be asked based on this. Few questions might be asked based on this concept. Right? So what is that? At equilibrium means, let's say it is N naught. Assume that is going to be N naught is a concentration of electrons at equilibrium. At equilibrium, at T is equal to 100 degrees Kelvin. At T is equal to 100 degrees Kelvin. Assume that it is N naught. So the concentration of the electron concentration obviously depends on the probability distribution function f of E, yes or no? Because it is clearly explaining. It is clearly f of E clearly explaining the energy level occupied by an electron. The energy level occupied by an electron then how many energy levels will be there? That is nothing but a constant. So N naught is directly proportional to the probability distribution function f of E. So this N naught is equal to a constant, something called NC, capital N, C into f of E. This is constant. So what is this constant where NC gives us energy density states in conduction band. Energy density states in conduction band. So what do you mean by this NC? What do you mean by this NC, sir? What do you mean by this NC, sir? So simple, sir. So this NC indicates how many energy states are there. How many energy states? How many energy states? How many energy states are there to occupy by an electron? To occupy by an electron. So this N naught is a electron concentration at equilibrium is directly proportional to f of E, that is probability distribution function, and that is equal to N naught is equal to NC into f of E, NC into f of E, NC into f of E. This is very important. So no way, what is NC, sir? What is this constant? Obviously the constant should have some value, right? So this NC is equal to it is very old value. Earlier you used to get problems on this. Nowadays nobody is asking problems on this, but still just for the derivation part I am trying to write. So need not worry, but understand this is a mathematical calculation. Energy density states in conduction band NC Mn into kT by h square power 3 by 2 into q power 3 by 2. Q power 3 by 2. So I'll write remaining here itself because if I go to the next page, you will miss the derivation. So NC is equal to 2 into so where Mn is, what is Mn? Where Mn is effective mass of an electron. Effective mass of electron, where M. Acha, I did not write M, right? I should mention that. Oh, I should wait a second. Sir. You have seen Mn, but let me write completely what is NC again. So NC direct value I'll write. It is a constant value 4.82 into 10 to the power of 15. 10 power 15 into Mn by M whole power 3 by 2 into T power 3 by 2 in terms of centimeter cube, where Mn is effective mass of an electron, and M is rest mass of an electron, rest mass of an electron. So what is the effective mass? Ideally, infinite energy states are present. Ideally, infinite energy states are present. See, yeah, electron can occupy any energy level at equilibrium, but for so if you try to divide, yes, it is infinite, but there should be some value. So for every point, not one, you can't say it is an energy level. You can't say it's energy level. So there should be a minimum number of uh, calculatable values. Because of that, Vasu we will consider. Because of that, we'll consider Vasu some energy levels as a considered as I considered, right? So now what is f of e, sir? Then f of e, that is f of e finding electron. F of e is going to be what? EC, conduction. We're talking about conduction electron, right? So conduction, f of c is equal to 1 by 1 plus e power EC minus EF by kT. EC minus EF by kT. Let EC is far greater than EF. If EC is far greater than EF, if EC is far greater than EF, so what happens, sir? So, so if EC is far greater than EF, E power, if EC is far greater than EF, then you get E power EC minus EF by KT is obviously far greater than 1. Far greater than 1. Now, can I write f of e is equal directly 1 by e power ec minus ef by kt. So, I can also write this as e power minus of ec minus ef by kt. This is f of e. Now, if you try to substitute in the previous equation, in this equation, what is f of e? So n naught is going to be nc into e power minus of ec minus ef by kt. EC minus EF by KT. This is the formula to be remembered. This is the formula to be remembered. Very important formula. Very important formula. Very important formula. So this represents the concentration of. So units are per centimeter cube. So this represents N naught is the concentration of electrons. Concentration of electrons at equilibrium. At equilibrium, N naught is equal to Nc into e power minus Ec minus Ef by Kt. Ec minus of Ec minus Ef by Kt. Sir, if you want to calculate what is this Ec minus Ef, Ec minus Ef, let's try to do that also here itself. So simply what? Apply logarithm on both sides. Apply logarithm on both sides. Apply logarithm on both sides. If you apply logarithm on both sides, now what happens, sir? You'll get shall I write directly? You simply will get minus of EC minus EF by KT is equal to ln of N naught by NC. Not by NC. And not by NC. And not by NC. So can I write this as a EC minus EF, EC minus EF, that is the energy gap EF, that is the energy, the range of energies where we can find an electron is the energy is nothing but EC minus EF is equal to KT into natural logarithm of, so this will become reverse, right? NC by N naught. NC by N naught. NC by N naught. NC by N naught. This is also important. Very important formula to be remembered. Many problems will be asked based on this formula. Many problems will be asked based on this formula. EC minus E naught. EC minus E naught. Sorry, EC minus EF. EC minus EF is equal to KT into, sir, for N type. For N type, N naught is going to be what, sir? Donor concentration ND or not? Donor concentration ND or not? So simply what it becomes? So for an N type, EC minus EF is equal to KT into natural logarithm of NC by ND. NC by ND. So this is also one of the formula you should remember. You should remember. Problems will be discussed on this. So even if you don't remember all these things, no problem. But just I request you to remember this or practice this. EC minus EF. What is EC minus EF? What is EC minus EF? EC minus EF is equal to KT into natural logarithm of NC by ND. NC by ND. NC by ND. Is that clear? Is that clear? So the f of E, the so this f of E is always nothing but probability of available, the function which represents the free electrons. The functions which represents the free electrons. Then what this 1 minus Fe represents? This is holes. This is electrons. So now if we want to calculate for hole concentration at equilibrium, hole concentration at equilibrium. Now if we want to calculate hole concentration at equilibrium, now similarly, but P naught, this P naught, sir, P naught is not directly proportional to 1 by Fe. P naught is not directly proportional to 1 by Fe. It is, so it is not F of E. It is proportional to 1 minus F of EV. 1 minus F of EV, and this P naught is equal to a proportionality constant which we have NV into 1 minus F of EV, F of EV, F of EV. Now, if you have some problem, you do one thing. This one, just this one. So you represent with yeah. Where again? What is NV, sir? Where NV is? Where NV is energy density states in valency band. Energy density states in valency band. Energy density states in valency band. And this is again, this value is going to be 1 NV. I'll directly write not like every earlier time. This is NV is going to be 4. Sir, earlier problems were asked on this formula. Nowadays, nobody is asking formulas on this formula. Temperature increases Fermi level moves towards the center of forbidden energy gap. Which case I did not get you? Which case I did not get you? Which case where it is moving? Where it is moving? I don't know where it is moving. So let me freeze this and come back to your question, Krishnaveni. Surely you will answer your question. So NV is equal to 4.82 into 10 to the power of 15 into MP by M whole power 3 by 2 into T power 3 by 2. This is going to be centimeter cube. Again, MP is effective mass of, where MP is effective mass of whole, and M is and M is rest mass of whole. Rest mass of whole. As the temperature is increasing, Fermi level is not coming down, right? Moves towards the center. No, it is not moving. Moves towards the center. It is moving toward top. So what's happening is here. So as the temperature is increasing in N type also, electron hole pairs are forming. This is what I am trying to represent. Here, this represent the above this energy level electrons are available. As the energy is increasing, this Fermi level increases. That's what we discussed in the previous in the beginning classes. As the temperature is increasing, let's say you have already 100 free electrons in N type, 100 free electrons in N type. So as the temperature is increasing, another 20 electrons will be added. Another 20 electrons will be added because the electrons in the valence bond will come out of the covalent bonds. When all these covalent bonds, see in N type originally due to doping, let's say you have 1000 electrons, right? In N type, due to doping, you have 1000 free electrons. As the temperature is increasing, what's happening, Krishnavedi? What's happening? What's happening? What's happening? Right? This extra electron hole pair formation, because of electron hole pair formation, extra electrons, extra holes are coming. So all those extra electrons and holes will be visible. So this is what I am trying to show. So here extra electrons, extra holes, these are extra holes. So earlier the probability of occupying an electron was this, but now it is increased. So it is moving closely. So earlier this was EF. What is EF? Fermi level. This is Fermi level, original Fermi level. EFI I can write. Intrinsic Fermi level. So obviously, as n value is higher than intrinsic Fermi level, it is more than this. Why conductivity increases? Because as you increase the number of holes and electrons, because of that, this energy, so electrons enters into the conduction band. So the probability of finding electron will be very high here, and holes also exist here. Holes also exist here. Clear? Okay. So now we'll continue with this derivation. So NV is going to be this. So now what is f of E, sir? We know that f of EV is equal to 1 by 1 plus e power EV minus EF by KT. But what we need 1 minus f of E. 1 minus f of E is equal to 1 minus 1 by 1 plus e power EV minus EF by KT. EV minus EF by KT. EV minus EF by KT. Right? So if you simplify, what happens, sir? So this is going to be 1 plus something and minus 1 by something. You will get what you will get is what you will get is so 1 minus f of e is going to be simply, can I write simply 1 minus f of e is going to be e power EV minus EF by KT by 1 plus e power EV minus EF by KT. As we know that as EV is far less than EF, so this e power this becomes minus e power minus infinity. So this entire thing will become 0 or not? Center thing will become 0 or not? So now, so 1 minus f of I'll directly write is I'll directly write so 1 minus f of EV is equal to directly e power, what is remaining, sir? EV minus EF by KT is remaining. EV minus EF by KT is remaining. EV minus EF by KT is remaining. So what is P naught then? So P naught is equal to NV into e power EV minus EF by KT. EV minus EF by KT. EV minus EF by KT. So this formula you need to remember. In some textbooks, it will be written as minus also. But it is not much required here. It is not required much here, right? So for a p type, for a p type, for a p type, for a p type, p naught is equal to Na. P naught is equal to Na. So Na is equal to Nv into e power minus. So for convenience, Ef minus Ev by KT. So apply logarithm and everything. What you'll get is apply logarithm on both sides. Apply logarithm on both sides. Both sides. And what you get is EF. I let P. P represents this one. Fermi level is equal to EF minus EF is equal to KT into natural logarithm of NV by NA. NV by NA. NV by NA. This formula also need to be remembered. This formula also. So how much shift is there in the Fermi level? What this indicates? EFP minus EV. That indicates how much shift is there in the energy level. How much shift is there in the energy level? That will indicate. That will indicate. So this formula. This is also important formula to be remembered. This formula to be remembered. This formula to be remembered. Okay. So EFP. So in the previous case, it is ECV, ECN you can call. Sorry, EFN here you can call. You can call this as EFN. So this is EFP minus CV is equal to KT ln of NV by NJ. Ln of NV by NJ. Ln of NV by NJ. Now we will see an important note before moving on to intrinsic semiconductor. So generally what happens, what is the Fermi level? So Fermi level for, now just wait here. Fermi level, how to calculate the Fermi level value, right? So Fermi level, this is derivation for Fermi level. Fermi level in intrinsic concentration, intrinsic semiconductor, in intrinsic semiconductor. Intrinsic semiconductor, right? So as we know, for intrinsic semiconductor, for intrinsic semiconductor, for intrinsic semiconductor, N naught is equal to P naught is equal to Ni. N naught is equal to P naught is equal to Ni. What is N naught? What is N naught? N naught is simply formula we have written just now. Nc into e power minus of Ec minus Ef by Kt we have written. Yes or no? Again here, what is P naught? This is Nv into e power minus of Ef minus Ev by Kt. So if you write Nc by Nv, Nc by Nv, you'll directly write, you'll get e power minus of 2Fi. So this is, you can write Fi, so that you will have a discrimination. So 2EFi plus NC plus, sorry. What is NC? EC plus EC plus EF by KT. EC plus EF by KT. EC by EF by KT. Apply natural logarithm on both sides again. If you apply natural logarithm on both sides, what you will get, sir? You will get simply ln of NC by NV is equal to minus of 2EFI plus minus of 2EFI plus EC plus EF by KT. EC plus EF by KT. So if you want to write something different here, so you bring it here and it is like, 2 EFI is equal to 2 EFI is equal to EC plus EF minus, it may not be visible for you if I write beyond the sum screen. So I'll try to EFI is equal to EC plus EF minus KT into natural logarithm of NC by NV, right? So what is EFI? Fermi level at intrinsic concentration is going to be EC plus EF by 2 minus of KT by 2 into natural logarithm of NC by NV. So as NC is equal to NV, what is remaining, sir? EFI is equal to EC plus all the time I am writing something wrong. You are not telling me. You're all sleeping, huh? You're all sleeping, huh? Time done. Your time is done. Arey, we are awake and we are doing all these things for you. How can you sleep, yaar? Wake up, wake up. Exam is approaching. Exam is approaching. Exam is approaching. You should not sleep now. You should be more cautious. You should be more cautious now. Every minute is important, sir. Every minute is important. Please wake up. This is the most important formula. EC plus EV by 2. This is the derivation. This is what the derivation. This is what the derivation. This is what the derivation. Now, similarly, we will try to calculate intrinsic carrier concentration. What is intrinsic carrier concentration? Ni. Yes or no? From mass action law, so intrinsic, to calculate intrinsic carrier concentration, from mass action law, Ni square is equal to N into P. Yes or no? So can I write N naught at equilibrium at N naught and P naught? Yes or no? So what is N naught? What is N naught? Now tell me what is N naught? N naught is NC into e power minus of EC minus EF by KT. What is P? It's going to be NV into e power minus of EF minus EV by KT. So what I can write here? What I can write here is Ni square is equal to Nc into Nv into e power EV minus EC by KT. EC minus EV minus EC by KT. EC minus EV by KT. So the Ni square, can I write this as a NC into NV into e power minus of EC minus EV by KT. So this is nothing but Ni square into NC into NV into e power minus, what is energy gap? EC minus EV is energy gap or not? EC minus EV is energy gap or not? So can I write this or not? NC into NV. NC into NV into e power minus EG by KT. EC by EG by KT. So if you substitute the value of NC and ND after substitution, after substituting NC and NV values. What is NC and NV value, sir? Go back and see here. So this is NV value. It is 4.8 into the power of minus 13 into MP by M 3 into 3 power whole power 3 by 2 3 power T power 3 by 2. Similarly here 4.8 into 10 to the power 15 to Mn by M into 3 power 3 by 2 into 3 power 3 by 2. So if you can see here, two 3 by 2s are there. Two 3 by 2s are there. If you put them at one place, what happens, sir? You'll get directly. What you will get directly, sir? What you will get directly? What you will get directly? So this is going to be Ni square into some constant A naught, some constant A naught into T power 3 into e power minus Eg naught by Kt. So this is the formula which we are looking for from many days. We have discussed about this formula earlier, sir. This formula we have discussed earlier. In our earlier discussions, this Ni square is equal to A naught into T cube into e power minus Eg by Kt. Eg by Kt. We discussed or not? We discussed, sir. Whether you remember it or not, we discussed this also. Where what the Eg naught? Eg naught is energy gap. Energy gap. A naught is constant, independent of temperature. K is Boltzmann's constant. And then T is temperature. And T is temperature. Temperature in degrees Kelvin. Temperature in degrees Kelvin. Eg naught is equal to energy gap. A naught is going to be constant, independent of temperature, constant, and K is equal to Boltzmann's constant. T is equal to temperature in degrees Kelvin. So from this what we can say is intrinsic concentration Ni square is directly proportional to T power 3. If you want Ni, so Ni is going to be something called A naught We will, in the previous case, we better assume is a naught square, so that it will be easy for you. A naught into t power 3 by 2 into e power minus eg naught by 2 kt. 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 Energy gap. Energy gap. So this is the formula which you need to remember also. This is the formula which you need to remember also. Many times problems are asked on this. You need not worry much about this. By practicing, you will get everything. Sir, immediately you may not remember everything. Immediately you may not remember everything. Need not worry. You need not worry. You need not worry. Immediately you may not remember everything. So, but slowly you will, once you start practicing, so you'll remember all these formulas. So here comes another note. A note we'll try to write here. What is that note is? We try to find out n naught in terms of ni. What is n naught? N naught is electron concentration in terms of ni. What is ni? Intrinsic concentration. Intrinsic concentration. So what we know is n naught is nc into e power minus of ec minus ef by kt. We know that ni is equal to same nc into e power minus of ec minus efi by kt. So if you write what is n naught by ni, you will get both ncs will get cancelled. Is going to be e power minus of ec minus ef by kt by e power minus of ec minus ef by kt, ef of I by kt. So what we can write is n naught is equal to ni into e power you can see what will going, sir. It's going to be minus ec plus ef, going to be plus ec minus efi by kt. Yes or no? So what will happen, sir? So this and this will get cancelled. So what will be remaining? N naught is equal to ni into e power ef minus ei by this simply ef minus ef by kt. So if you want to take minus, generally minus will take in common. N naught is equal to Ni into e power minus of Fermi level energy minus EFC by KT. This formula you can remember. This formula you can remember. Or if you want, you can also write one thing. So simply you can write N naught is equal to Ni into e power minus of EI minus EF. Directly you can remember this also. You need not write all those things. So you can remember this also. This can also be a formula. This can also be a formula. This is also a very important formula. This is also a very important formula. So today's class is a bit boring, I know, because these are all derivations. These are all derivations. Sir, if you have to concentrate more on to understand all these things, you have to concentrate more on everything to understand all these things. So I request. So if it is P naught, similarly, what is P naught? P naught is going to be Ni into e power minus of EF minus EI by KT. This is also important formula. You have to remember. You have to remember. You have to remember all these formulas. You have to remember all these formulas. Shall we do one problem? Shall we do one problem? Only one problem, sir, today. Then we will close the session. Need not worry. We'll do one problem here. We'll write a problem here. We'll write a problem here. Tarak. Very good, Tarak. Calculate the position of Fermi level, Fermi energy level. I'll write a problem. Calculate the position of Fermi level, Fermi energy level in N-type silicon, in N-type silicon at T is equal to 300 degrees Kelvin with respect to the intrinsic concentration, intrinsic Fermi level, given Fermi level given Nd is equal to 2 into 10 to the power of 17 per centimeter cube, and Na is equal to 3 into 10 to the power of 16 per centimeter cube. See, what is this? Calculate the position of Fermi energy level in N-type silicon at 300 degrees Kelvin with respect to the intrinsic Fermi level. the intrinsic Fermi level. The intrinsic Fermi level. So what it has given, what is expecting. So as it is, sir, as it is n-type, as n-type silicon, so obviously the Fermi level will be above. Fermi level will be above the, yes or no? The Fermi level will be, if this is the intrinsic Fermi level EF, if this is the intrinsic Fermi level EF, so this is where your new Fermi level will be. New Fermi level will be, right? So this is, I can write EFI and I can call this as EF. EF. Just now we discussed, sir. Just now we discussed. What we have discussed, go back and see. Go back and see what we have discussed about this. So what is expecting? Is expecting EF. EF. With respect to what? With respect to EI. With respect to EI. So do we have any formula for this? So what is Fermi energy level for n-type? What is Fermi energy level for n-type? What is Fermi energy level for n-type? This is what? Yes or no? This is what? Yes or no? Yes or no? Respond. Not listening. Sleeping. Okay, I'll write the formula only. I'll write the formula directly in terms of EFI. Sleeping, yeah, yes, sleeping. All of you sleeping. Reply is sleeping, right? Reply is sleeping. So the formula is going to be EF minus EI is equal to KT into natural logarithm of N naught by Ni. That is equal to KT into natural logarithm of natural logarithm of natural logarithm of N naught. Can I write ND? N naught, it can be ND, right? N naught can be ND. So what is the intrinsic concentration? Did he give intrinsic concentration? Sir, see, in the given problem, this is given to confuse you. No use of this, Na. No use of this. But he's saying it is N-type silicon. N-type silicon. What is Ni for N-type silicon? Nd he has given. Nd how much he has given? 2 into 10 to the power of 17 or not? Per centimeter cube. So then what is Ni for silicon? Intrinsic concentration for silicon. Yesterday also we have done some problem on it. 1.5 into 10 to the power of 10 per centimeter cube. Per centimeter cube. So, and K is Boltzmann's constant. K is Boltzmann's constant. K's value is 8.62 into 10 to the power of minus 5 electron volts per Kelvin. So T is how much? 300. Substitute all the values. Substitute all the values. So what you will get is EF minus EI. EF minus EI is equal to, so ND is KT is K is 8.62 into 10 to the power of minus 5 into 300 into, I'll write here because it may not be visible for you. It is 2 into 10 to the power of 17 by 1.5 into 1.5 into 10 to the power of 10. How much you'll get, sir? Can somebody tell me how much is the value of this? Can you please calculate? Please calculate. Can somebody calculate this? EF minus EI. Calculating or not? EF minus EI. 200, 200.9 10 to the power of minus 5. Oh. Probably you might have used log, not natural logarithm. You should use ln. You should use ln. Krishnaveni, you should use ln, natural logarithm, and try to calculate it again. You'll get some other value. You'll get some other value. EF minus EV is going to be 0.424 electron volts you are supposed to get. So what is EF? The new Fermi energy level, EI plus 0.424 is what the answer is. Is what the answer is. Is what the answer is. So how to understand this answer? How to understand this answer? How to understand this answer? So this new energy level is above EI by a energy level value of 0.424 electron volt. 0.424 electron volts. It means, so this gap is going to be 0.424. This gap is going to be correct, Krishnaveni, correct. Now you got the answer. Clear? Now you got the answer. Now you very good. Okay. So we'll stop it here. So tomorrow's class. In tomorrow's class, we'll discuss about generation recombination of charge carriers, and we will discuss continuity equation, and we'll also discuss Hall effect, which are the very important topics. Generation recombination, continuity equation, and Hall effect are the important topics. Which we will try to discuss tomorrow. Please don't miss tomorrow's class. But tomorrow is going to be how much as date? It's going to be 19. That's what, right? 19/12/2020. Right? So this is what our Unacademy Gate Telugu Telegram channel, Unacademy Gate Telugu. This is what the YouTube also we are discussing. So YouTube, which we are discussing right now on same YouTube, and a Telegram channel is also having Unacademy Gate Telugu. And we have many other channels. We have many other channels also. So Gate, EEECEEIN. This is for instrumentation. For electronics communication, electrical engineering, we have one, right? And for Unacademy Gate also, we have Unacademy Gate for mechanical engineers, production engineering, and this is engineering sciences. For that, we have one channel. Unacademy Gate Civil Engineering, we have one channel. Unacademy Gate Civil Engineering, we have one channel. And we have one another thing called Engineering Pathshala. We have called another thing called Engineering Pathshala. We have Unacademy Computer Science. This is also useful for IT students. And we have Unacademy Gate questions. So those who are targeting for 2021, I would request you to just go through this Unacademy Gate questions. You have all the previous year Gate questions or any extra Gate questions for branch wise, exclusive that the previous year questions are discussed. And of course, in this channel also, we are going to discuss soon, hopefully, previous year questions. So all previous year questions or multiple choice questions or many important questions will be discussed on this Unacademy Gate questions. And we have Unacademy Gate Telugu, on which right now I am teaching and many other faculties also teaching. Unacademy Gate Telugu, also another channel which we have. We have another channel called by name Electrical Junction. Electrical Junction is exclusively for electrical students. So those who are targeting for 2021, 2022, so all even 2022 and 2023 students, those who are targeting for GATE 2022 and 2023 students. So I request you should all register for this. All free courses are running. Unacademy is running free courses, many free courses also. So don't miss. Vasu, you are asking for lecture PDFs, right? Lecture PDF will be available on this Telegram channel. I will ensure that you will get this on Unacademy Gate Telugu, channel. On Unacademy Gate Telugu channel, I will ensure that you will get these notes. Not only this, probably all the previous class notes also we will try to post. All the previous class notes also we try to post. So, but you need to join in this Telegram channel. Okay, Vasu, is that clear? You just type in Telegram. You just type Unacademy Gate Telugu, or just type Gate Telugu. You will definitely get this. Is that clear? Okay. We'll catch up tomorrow. Thank you all. So don't forget to like, share, subscribe to the channel, and don't forget to hit the bell icon. Hit the bell icon. Hit the bell icon. Please hit the bell icon. Right. So please like the class and share it with your friends. And then this is subscribe, and then we have channel. Thank you all. Thank you all. Good night. Catch you up later.